We're live. The MCAT stream will say, hello, you there? Hopefully sound is coming through. It looks like everything's coming through. All my plugs are sorted. We've got it here. Welcome to Nutshell Maths. Yo! How we going, team? Looks like we are ready to go hard. Right. Thank you, my dude. Alright. Let's get ready to rumble. So, welcome. We are doing a level 2 probability tutorial. For those that are new here, welcome to Nutshell Maths. 3 things you need to keep in mind. First, you can create a free Twitch account so that you can write comments in the comment bank. I constantly look at chat. If I'm looking this way, I'm looking at chat. If I'm looking this way, I'm looking at my screen. If I'm looking downwards, I'm looking at my question. So create a free Twitch account and leave a comment, leave a follow, drop a sub if you're keen. Right. 2, get out a pen and paper. Okay, you need to do the maths while I do the maths, otherwise you don't get anything out of this. So you must work alongside with me and ask lots of questions. That is the point of the live stream. Get out a pen and paper. If you want access to the questions, exclamation questions in the chat. If you want access to the answers, exclamation answers to the chat. We are doing the 2018 probability methods paper. Before I get started, same thing as yesterday. You guys get a choice in the matter. Okay? Back in the bathroom. No, it's a tiny study. Right. You get a choice here. First things first. You can choose between the black pen or the blue pen. Right. Spam chat, please. Black or blue. Right. Last night I was working in blue. Tonight, who knows? Maybe it'll be different. Right. Spam chat, please. Right. I want to see what you want. Blue or black. Your wish is my command. Okay. We got some whites. Blue or black team. And then also I've got music softly playing in the background. Tell me if you want that off as well. Oh, it's looking pretty even. Blue, 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 black, blue, 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 blue. Oh, most stuff said blue. I've got to go with blue, to be honest. Got to follow my stuff. Apex Legends ad, they're not controlled by me. Okay. Looks like we're going blue again, team. We got a blue. Let's do it. The other thing is music on or off. Okay, music on or off. Got to make sure this calculator's here. Music on or off. I've got it softly in the background. You might not even be able to hear it. Okay. Music on or off. Looks like, okay, Panda. I'm hyped. I'm ready to go. Right. I'm just talking quietly because no one, there's people home. But let's do it. I'm hyped. I'm ready. Let's get into it. Okay. This could be a quick stream if we are pumping. Right. But you have to slow me down if I'm going too fast. Okay. Blue's the way. Music, music, music. Imagine being hyped for maths. Imagine not being hyped for maths. Imagine not being hyped for your job. Right? Lame. Right, let's do it. Okay. There's a lot of words in this. Each day temperatures are recorded every hour at various locations around New Zealand. The National Institute of Water and Atmospheric Research, NCEA, obtains the daily temperature by finding the mean of all recorded temperatures in one 24-hour period at that location. Blah, 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 blah. Right? Over the last 7 years, daily temperatures in Reefton have been found to be approximately normally distributed with a mean of something and a standard deviation of something. Use this info to answer the questions. Okay. There we go. Find the probability that a random chosen date in Reefton. How I do all these questions is I draw the picture, do the maths. Always start by drawing the picture. So my normal distribution curve looks like this. I always put the mean in here. 11.6. Oh, yep, mean. And I always put the standard deviation up in this top right. If you do this step, it's very hard to get the next part wrong. Okay. Someone wants to fight me already. Jeepers. Okay. If you do this step, it's very hard to get the rest wrong. So, once we're here, we go to our graphics calculator, or actually we look here and we go find the probability that a randomly chosen day in Reefton would have a daily temperature between 11.6 and 18.8. So that's going to be between there and 18.8. That's going to be this area here. So I've drawn my picture. Now it's ready to do the maths. Good evening, Jimmy. How are we going? So to do the maths, we go to stat. We go distribution, normal, NCD. I'm going to do that one more time for those that are a bit slow. Stat, distribution, normal, NCD. And I just take all this information from my picture. So on my picture you can see 11.6 is my lower. 11.6, bang. My upper is this top region here, 18.8. Bang. My mean is 4.8. Sorry, my standard deviation is 4.8. And my mean is 11.6. Let's hit that calculate button. 0.433. Check on exclamation questions to see the question, and you'll have access to the paper straight away. We're doing the 2018 paper. 0.433. Done. Achieved. That's it. Right, that's it. Draw the picture, do the math. Draw the picture, do the math. If you can draw the picture and do the math, we can get a merit easy in these first 3 questions. Right? So let's have a look here. Find the probability that a randomly chosen day in Reefton would have a daily temperature over 17 degrees. What are we going to do? Draw the picture, do the math. 11.6. Our standard deviation is still 4.8. 17 degrees is up here somewhere. We'll have a daily temperature over 17, so I'm going to shade all this in. And I want this probability. Not too bad. Is Chris Ban? Nah, unfortunately not. He reckons it wasn't him that was cussing me out. Right. So our lower in this picture is 17. Our upper is a really large number. No. Because it goes on forever. Right, if I shaded this in on a normal distribution curve, it goes forever in that direction. Okay. So I just put a really large number. Everything else stays the same. Bing, bang, boom. Here's our probability. Probability 0.13. Okay. Thanks for the follow, my dude. Right. So far, so good. You should have your graphics calculator. If you don't have a graphics calculator, you are throwing away free credits, right? You've got to go and buy one. Right? Any questions so far? We're looking pretty good. Right? Let's have a look at this now. Before we pass maths, jog, that still is a chance. And you will increase your probability if you tune in for the whole session. Must have. Nice, thanks for this follow, dude. Okay, people in Reefton talk about the hottest 1% of days as being scorches, mate. That's a real Kiwi thing. What is the lowest possible... Man, my Google on my phone just started listening to me. Scary. What is the lowest possible daily temperature of a scorcher? So, let's do it. Probability is just reading. Is that... Who said that? You've quoted it like as if I've said it. Yeah, it is pay to win. Probably is pay to win, dude. Right, the hottest 1%. So above some value, x. Oh, actually, before I even do this, let's put in my mean, 11.6. Let's put in my standard deviation of 4.8. So there's some value here, and everything above this is 1%. Which is 1%, right? So, if everything above this is 1%, then we want to find this, what this is, everything above this. To do that, we do the inverse normal function on our calculator. So we go stat, distribution, normal, inverse normal. Right, if you have a fancy new calculator, you will have this tailed section. If you have a old green calculator, you will not. If you have an old green calculator, it always calculates from the left. Right, spam chat now if you have an old green calculator, and I will explain it. If you don't, then I will not explain it. Because if you have a nice one, you can just choose the tail direction. Left, right, or center. Right, we're going to go from the right because it's shaded from the right inwards. Okay, so let's make this right. Our area is 0.01. Our standard deviation 4.8, mean 11.6. And there we go, 22. 22.766. What have we just found? This temperature is the temperature at which everything above this is 1%, or only 1% is above this. Right, can we do it again? Sure thing. Right, I've got my picture. Let's erase this. Okay, I've got my picture. No worries. It says people in Reefton talk about the hottest 1%. So probably past some value is the hottest 1%. Let's shade it in purple. Okay, the hottest 1%. Right. If we go to our inverse normal function, we want to find what this x value is. We're going from the right, because it's shaded from the right hand side. The area is 1%, which is 0.01. Our standard deviation is 4.8, and our mean is 11.6. I'm about to sneeze, I think. No, I think it's gone. Oh. Now we're Gucci. Okay, so we've got all that sorted. We hit enter, 22.766. So yeah, hopefully that's helped you there. Okay. Do I do physics level 2? I don't know if that's at me or at other people, but if it's at me, no, sorry. The SDM mean came from over here. If you tuned in earlier, you would be here. Right, previous question. Okay. Right, here's the hard question. Here is the hard question. So, if you don't understand what I'm doing here, if you haven't learnt it, if you're in my class, you probably haven't learnt it. Right? If you don't understand it, no stress. Right? It's an E question, it's a hard E question. You can just move on. If you do understand it, let me show you how to do it. So, using this normal distribution approximation, the probability of a daily temperature lower than 9 degrees is, so lower than 9 degrees is 29.4%. Okay, suppose, so that's with a mean of 11.6 and a standard deviation of 4.8. Suppose that everything got hotter, but the standard deviation remained the same. Then what would the mean daily temperature need to become to make this probably 4 to 20%? So what we're going to do is we're going to normalize this. Okay, and we're going to find what's the z value here that gives this, right? What is the z value? Let me very quickly check. This is what I did. I've done the whole paper already, look, but I did it in black pen, so it's probably better, right? So we go to oh, that went small. So we're gonna go, tail is left, area 0.2, so we want this to be 20%. 0 and 1. No, wrong way around. 1, 0. So we're doing the process of normalizing. Okay, if you've not learnt this, it is quite tricky. It might be worth skipping in your test, but also it might be worth learning. So we are normalizing this to find the z value, which we've got 0.8416. Okay, well it's negative, but it sort of doesn't really matter. Right? So we have our formula. I always forget this formula. Z equals x, no, not x, the mean minus x all over standard deviation. I'm pretty sure. Z equals the mean, which is what we don't know, minus the x value of 9 all over my standard deviation of 4.8. Okay. Minus 0.841 times by 4.8 and plus 9. Okay, that's not right. What have we done wrong? Maybe it's not even meant to be negative. 4.8 times 0.8416 plus 9. I think that's right. Or is it x minus the mean? Have I done the formula wrong? I told you I always get it wrong. No, it's mean minus x, I'm pretty sure. You're trying to trick me. That's what I've done wrong here. I just did the negative differently. Or is it actually x minus the mean? Oh, that actually makes sense. I always forget this formula. Oh, it's x minus mean. Okay, that's why the positive and negatives are around the wrong way. That's all good. You'll be given the formula, so it's no stress. Right, mistakes happen, such as life. X minus the mean. 9 minus the mean. So we've got this formula here. Let's move this stuff. Can we rotate it? There you go. Boom. Okay. So we've got this formula here. We've got minus 0.8416 times 4.8 equals 9 minus the mean. Type this in. 4.8 times minus 0.8416 is minus 4.04 equals 9 minus the mean. We subtract 9. Minus 13.04 equals minus the mean. Therefore 13.04 is the mean. Okay. Right. I know this is a little bit hard. It's certain to solve it. No, Solver's not good. If you're doing these sort of questions, you should not be relying on Solver. Okay. Right. I can do that much quicker than you can type in Solver. I promise you. I don't know if you'll be given the formula in Calc. I don't teach Calc, but you should. I think he wants you to use formula. I use Solver. Yeah, you can then. Right? Listen to your teacher more than me. Right? So, this equation is always there. Right? It's going to be in your exam, I promise you. It's always there. You normalize first to find the z-score. Then you plug it back into the formula with all the old information to find the new mean or the new standard deviation or whatever it is. Okay? Normalize, find z, plug it in. It looks harder than it actually is. Okay? Right, so far we've got E, but let's do the other E question. Now this was a really weird E question. And I had a look at it, I was kind of, not confused, more just like, heh, when I looked at it, right? Oh my god, E questions, yeah I know, right? Show that for any normal distribution, the interquartile range, IQR, is always greater than the standard deviation. Okay? There is so many different ways to answer this. Honestly, I'm not going to go into too much detail on this question. You can just look at an exemplar or look at the answers, exclamation answers in the chat. But what I will say is this. By definition, this is always true. Let me explain. So, a standard deviation is created by being always, roughly, if I have the mean here, and I have minus 1 standard deviation and plus 1 standard deviation, there is always approximately 68.7, I think the number is, percent, or something like this. Okay. There's always 68% in there. Roughly 68%. That's how the standard deviation works. That's what it's like. The 68% picks what the standard deviation is, not the other way around. Okay, it's like I lay out all my data, I grab the middle 68%, I find what those values are, and that's my standard deviation. Okay, so therefore, can you stop spamming please? 30, so it's 64. I'm right. I have 68, 64, whatever. Right? It's like 60 something. I always forget the number. The number's not important, right? 64, 68, whatever. Right? What's important is that the percentage creates the standard deviation. Right? And if the percentage creates the standard deviation, that means it's always like that. It's always like that. This means that this area is always 64%, but the IQR of the same curve is always 50%. Again, that's the definition of the IQR. The IQR is 50%, the middle 50% around the center. The standard deviation, plus or minus 1, is the middle 68 or 64%. Okay. This is the reason why this is true. Now they want specific things. I will just look at the answers and see what they want. There's lots of different ways to explain it, right? Sing will definitely have a better way to explain it than I do, but that's how I think about it. Let's look at what the answers wanted explicitly. Right. They got this, right? So you get an E if you make clear conclusion that IQR is bigger than the SD. Response must be based on the z-axis, not probabilities alone. Makes clear generalization to all normal distributions. So if you write something that's very clear, you get it right. They said SD is how much the SD is away from the z-score. Yeah, essentially, right? What you could do, another way you could do it, is actually use the numbers like what this is said here. If you actually use the numbers they give and compare the two, so you find the middle 50% versus finding the middle 68%. Use the lower and upper of the SD and then inverse normal the other way, and you'll get different values, and you'll be able to find that. Okay. However you understand this, you just spit it out. Okay? But it is kind of weird, and it shows that if you understand this deeply, you can write it. If you don't, you can't. Okay? So it's like a good excellence question because it tests you. But it's kind of nasty because you can't really prepare for it. Okay? If there's no questions, let's move on. Right, if you're still in the chat, make sure you say hello. Right? We've still got Panda going hard, even though she's year 11. Okay, here we go. Nice and easy, these ones. Right? Blah, 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 blah. This whole top part is like low-key useless. Right? This whole thing. But let's read it anyway. Mathieu analysed Kaitaya's daily weather data from NCEA from the last 7 years. He classified a day as windy if the mean speed was above 36 and still if it wasn't. He classified a day as wet if it had more than 2 mm rain. Otherwise he didn't. He summarized his table in his analysis in table 1 below. Right? You guys can definitely answer these questions before I do. So answer the question, spam it in chat to make sure I know that you're paying attention. Right? We're using blue pen, right? So use table 1 to answer the questions in part I through to 3 through 3. What proportion of days over this time were windy? Days over this time. This is how I teach this. Okay? Right, this is how I teach it. I teach this concept of want over pull. The idea is how much you want over top of the pool of things you're selecting from. Okay? And in these sentences here, you often get given the pull first and then the want second. Okay? Often, not always, but often. So, what proportion of days over this time? This is my pull. Were windy. So out of that selection, how many were windy? That's our want. Want over pull. Okay? Want over pull. Let's have a look. So, the pull is this one here, 2556. And our want is out of that, how many were windy? Well, there was 1646 that were windy, which I've grabbed from here. That over that. Okay. So we put that over that, we get the achieved. Nice and easy. Again, what portion of wet days over this time were still? Of wet days, that's our pull. Were still, that's our want. And remember, our want can never be grabbing stuff that is outside of our pull. Okay? It doesn't make sense. You can't select things that are outside your selection. So, out of all the wet days, so we got all the wet days going this way. The total of the wet days is here. So out of all the wet days, 641. How many of those days were were still? 88. So we've got 88 over 641. Okay. Hey Khalifa, how you going? Someone's just spamming answers to other questions. That's not cool. We'll just do this for a bit. No worries. No worries. Okay. Right. Are we all good with that? That stuff is the easy stuff. That's 2 achieves right there. Let's check the answers. We can leave it as a fraction. 1646 over that, 88 over that. Not too bad. 1646 over that, 88 over that. Easy peasy. Okay. Right. Let's have a look at this. Over these years, is it more likely to be wet on a windy day or wet on a still day? The way I do any of these comparison sort of questions is I do what I call like a versus. Okay. One versus the other. Wet out of the windy. I write it like this. Wet out of the still. If you write it in words first, you understand it way better. Okay? If you write it in words first, you understand it way better. Wet versus windy. Sorry, wet over windy versus wet when still. So let's have a look. Let's call this one yellow. Let's call this one pink. Right, we got wet when windy. So all the days when it's windy, 1646. That's all the windy ones. How many of those were wet? We're going across. Wet when windy, 553. Versus, out of all the still ones, out of all the still days, we got 910 still days. How many were wet? We've got this number here, 88. So we've got 88 out of 19 versus, or 553 out of 1646 versus 88 out of 19. Okay. Right. So far so good. We want to just compare these two numbers. To compare these two numbers, it's way easier if they're decimals. Right? 553 out of 1646. So this is going to be 0.336 versus 88 out of 19. 0.097. Now let's read the question and see how we answer. Over these years, is it more likely to be wet on a windy day or wet on a still day? Wet on windy is more likely than wet on still because this is bigger than this. Bigger, smaller, more likely, less likely. Starting to lag. Okay. More likely and less likely. So you can write a little sentence there. More likely, less likely. Right, let's check what the answer said. It keeps doing this. So you calculate these two, boom, boom. You compare the two. Both probabilities correct with the correct conclusion. Yeah, you need this conclusion here to get the merit, which is what we did. Easy peasy. We got merit. Okay. Not too bad. Easy merit, I think so. Comparing probabilities is a nice way to get a merit. If there's one in there, then you should take it seriously and know it's a merit, maybe even excellence. Okay. Easy. Yo, I love that emote. That's a nice emote. Oh, it's from Summit 1. We need like a easy E emote. We need an easy E emote. Maybe that's something I can get sorted. Easy E. Right, let's have a look at this. Right. A school in Qatar is planning its athletics day, blah, blah, blah. So this is like another one of those weird, deep thinking questions. But it's not actually that deep. Right? Think about this. When I read this question, I have to flick back. So you should do. You should too. You should do. You should too. A school in Qatar is planning its athletics day for February 2019. The sports coordinator uses the information in Table 1 to calculate the probability of the day being dry and still. Give one statistical reason why using Table 1 might not lead to a valid probability. So let's look at where they got the information from. Okay, because there's nothing wrong with the info, but where'd they get it from? Mathieu analysed Qatar's daily weather data from NCEA for the last 7 years. So he's just grabbed it online for the last 7 years. Okay. If I look back here, a school in Qatar is planning its athletics day for February 2019. Okay. Can someone tell me the problem here? I'll give you a small hint. Oopsies, that's not the hint. This is the hint. Small brain. We need a big brain emote and a easy E emote. Global warming G? Yes. Roscoe Athletics. February is hot and not rainy because it's summer. Jog Jansen. Easy E for you. Okay? That's literally all they are looking for. They're looking for you to identify that. This data came from 7 years worth of stuff. He's trying to make they are trying to make a prediction of Athletics Day in February. Chances are the year-long data is going to be different to what we need in February. That's all you need to write down. Data was from all year. This is not an accurate representation of February. Oh, I can't spell. February. Okay. Yes, every live stream gets uploaded automatically. Data was from all year. This is not an accurate representation of February. Feb would probably have a higher prob of being dry and still. It's not often it's raining and windy. Okay, in February. We good? Let's have a look at what the answers expected us to write. So, if you were, who said it in the chat? Someone said this. If you said global warming G. Okay, that's sort of implying this. The old data is different to the new data because it's old. Okay, if you use that excuse, you get a merit. Sorry, you get an achieved. Okay, you get an achieve. If you said, if you were Jog Jansen, you get a merit. Okay, easy A for quantum, easy merit for Jog. Easy my G. Okay, not too bad. Any more questions? Oh, one more question. Right, this one gets me looking forward to it because I see this here. And I already know it's worth excellence and I already know how to do it. Right? These questions are asking for the relative risk. Matthew claims that it is 20 times more likely to be windy, blah 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 blah. So I know it's going to be a relative risk question. Right? So he wants to compare the weather in Kaitaia with the weather in Reefton where his brother Tamati lives. He performs the same analysis of weather data for each town to obtain the summaries in table 1 and 2. Right? Okay. So, let's do the same setup, something versus something. Matthew claims that it is 20 times more likely to be windy when it is dry in Kaitaia than when it is in Reefton. So, windy when dry in Kaitaia versus the same situation in Reefton. So let's have a look at this. Windy when dry. So when dry, 1915, and windy. Out of these ones, let's highlight this. This is our dry situation. Our windy one is only this. So we're going to have 1093 out of 1915. Okay? And our other one, we've got windy when dry for Reefton. Let's have a look. When dry, windy. So we've got 53 out of 1673. And we're going to compare these two. Right? We're going to compare these two. We're going to compare these two. Right? 1093 out of 1915 is 0.602, so you got like a 60% chance versus 3 out of 1673 is 0.032. To find the relative risk, I'm going to write it over here. Relative risk. We do the first probability over the second. First probability over the second probability. That will give us the relative risk. So let's do that now. 0.602 divided by 0.032. We've got 18.8125. Now our last step is to compare this to the claim that he's made. The claim that he's made is 20 times more likely, and we've calculated 18.81. What do we say? Do we say he's right because it's basically 20, or do we say he's wrong because it's not 20? Right? Do we say he's right or wrong? Please say it in the chat. Right or wrong? Right or wrong? Do we say he's right or wrong? Right, we got some wrongs. We got some surely give him some leeway. Man's doing his best. Yo, I agree. Wrong. You guys are aggressive, man. Tell you what. We are nice. We can say, when I say we're nice, I mean I am nice to you, or the markers are nice to you. Situation 1. Wrong. It's 18.8, not 20. He exaggerated. Or right 18.81 or whatever is close enough to 20 that he is basically right. We can do both. Let's look at the answers, right? The answers say situation 1. He calculates the correct relative risk but concludes that he is correct through rounding or otherwise. Option number 2. Calculates the relative risk and concludes that matter is not correct by accurately using the relative risk. So you sort of can be right in both situations. I think that this one is more correct. And I think the answers agree because they've given a T1 here and a T2 here. And T1 is worth E7, T2 is worth E8. Do we give both reasons for E? Good question. No. You should probably stick to your one reason. Right? So they preferably like quite accurate claims. Right? So if it says 20 times and it is actually 18, like in this example here, then you say no, he's exaggerating. Right? And leave it at that. If it was like 19.97, then I would say, yeah, he's all good. Right? But this is quite an exaggeration. You sort of have to just take it with a pinch of salt, right? I saw a question from His Grace. You did 1093, not 1915. I did dry. I did windy out of dry. Oh, I see. I just typed into my calculator wrong. Here. Oh yeah, good point. Okay, so my calculation is slightly wrong, isn't it? Yeah, you're right. 1093 divided by 1915. I see. So this should be, yeah, it should even be more worse, right? 1057. 0.57 divided by 0.032. Yeah, it's even worse. 17.8, right? Sorry. I would have even got it correct, I think, if I got that answer. I would have still got it excellence. Okay. Indeed, more worse. Yeah, forgive me, for I can't speak. Yeah, look, I've made like 2 big mistakes on this test. And I'm still doing okay, right? You should make mistakes, you should iron them out, you should check your work. This is why you should check your work as well. If you're in B band, you've got 3 hours to do these 2 papers. If you're in A band, you've got 1 hour to do 1 paper, basically. Right, this is the hard question. Let's do it. We're almost under an hour. This should be quite short. It's not too hard. Okay, need to find some data. They love the weather, right? In this one. Okay. So, I need to find some data over the past 7 years. She analyzed the data and finds that it was wet on 45% of days in Ashburton. If it was wet in Ashburton, the probability it was wet the same day was Timaru. If it was dry in Ashburton, the probability it was dry on the same day in Timaru was this. Right? So, this sentence here or these two sentences, are really important, especially this part. If it was wet in Ashburton, then something else happens. Okay? This is telling us that whatever happens in Ashburton determines the probability for Timaru. So they come after each other, they rely on each other. Right? So if it's wet in Ashburton, then we look at Timaru. Let's move this around a bit. That's what this if it was wet is really important. It's saying it follows after it. Okay. If it was dry in Ashburton, then we look at Timaru. Now let's look at this probability stuff. Wet in Ashburton 0.45, which makes this is 0.55. If it's wet in Ashburton, the probability is wet on the same day in Timaru is 0.63, which makes this 0.37. I'm just subtracting from 100. 0.88, 0.12. Okay. Anyone got any questions on this? I want to calculate each of these probabilities. Let's go wet, 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 dry, dry, wet, dry, dry. Right, so to find them, we times it on the branches. 0.45. Oh my gosh. 0.63. 28. Tell me if I type in anything wrong on my calculator. 0.45 times 0.37. I did this paper last year, nice. How we get the 0.37? We've just subtracted it from, so this must be 100, right? It's 100% that it's wet or dry. So if we know that 63% wet, then the rest must be 37, which is 100 minus that, or 1 minus that. Okay? Let's keep calculating. 0.55 times, 0.55 times 0.88, 0.484, and I've done it in the wrong place. That's fine. 0.55 times, I'll fix that, 0.12, 0.06. So let's move this down here. And 0.066. So to do your check, you add all that stuff together. Right, let's make sure this is okay. Yeah, lots of people hate trees. E7, E7, A3. Sucks, dude. Right. Let's read the question here. Find the probability that it was dry in both Ashburton and Timaru. Dry in both Ashburton and Timaru. That's this one here. So we're going to put 0.484. Done. Nice. Find the probability that on a randomly chosen day only one of the towns was wet. One of the towns was wet. Only one, not at least one. This one and this one are both the ones that contain only one. 0.1665 plus 0.06, because it's one or the other, so we plus 0.1665 plus 0.066. 0.2325. Done. Let's double check we've got everything right. 0.484, 0.2325. So far so good. Got some chemistry going on in the chat. Right, no more questions here. We're going to have to keep flicking back and forth here. This one is an interesting one. Okay, this is your merit. It's a conditional probability. If it was dry, so that's really important. If it was dry, that's the condition. It might sometimes say, given that it's a dry day in Timaru, do this and this, or if it was dry. What is the probability that it's also dry in Ashburton on the same day? So this is our pool. A dry day in Timaru. And this is our what? A dry day in Ashburton. Okay? So, a dry day in Timaru. A dry day in Timaru is, let's erase these really quickly. Dry day in Timaru. Dry in Timaru, this one. Or this one. This is a dry day in Timaru. So our pool is 0.1665 plus 0.484. That's all the situations where it's a dry day in Timaru. Okay, 0.1665 plus 0.484, 0.6505. Now our want is a situation within those that it was also dry in Ashburton. So we must choose from this or this. But we want the one where it's a dry in Ashburton. This one is dry in Ashburton. This one is dry in Ashburton. So we're going to use this one as our want. Our want is 0.484. You'll notice that whenever you do these conditional probability questions, this number is one of the numbers that are in here. See this? It's one of these numbers. In this case it's here. So want over pool, we do want 0.484 over top of 0.6505, which is divided by that one, 0.744. Done deal. Merit question. Whatever comes last in the question, put it on top. It's a good rule of thumb. Not always the case, but it's a good rule of thumb. Okay. Right. Cool beans. Last question of the paper. No, not last question. Second to last question of the paper. Right, this is kind of a funky one. Nancy is planning a one-day bicycle ride from Ashburton through Timaru, then to Waimata. Nancy's grandfather says that in his experience the probability of it being dry in all three towns on the same day is somewhere between 30 and 35. So, we have dry in Ashburton, dry in Timaru, and then dry in Waimata. Okay. The probability of it being dry in all of these three, so this times this times this, is either 0.3 or 0.35. On the day of Nancy's ride, it's both dry and ash, so we've already got this condition. Dry in both. Okay. If Nancy's grandfather is correct, what is the smallest probability that is a wet day? Right, this is the key. Smallest. Right. Smallest wet day equals largest dry day. The smallest probability of a wet day is the largest probability of a dry day. Okay, so I only care about this large probability of a dry day. Right? So, this is the hardest question to wrap your head around. The probability of Ashburton dry and Timaru dry. This is where I'm looking. we've already done Ashburton dry, Timaru dry, 0.484. So this whole thing here, some number times some number, is 0.484. So we got 0.484 times by another dry probability is equal to 0.35. Right? Yeah, I do have a headphone bump. Okay. 0. But only when I'm wearing headphones. So to find what this unknown is, we can go, the unknown is going to be 0.35 divided by 0.484. A little bit of rearranging. 0.35 divided by 0.484, which is 0.723. This is the probability, the highest probability of a dry day. This is the largest probability of a dry day, which means the smallest probability of a wet day is 1 minus this. 1 minus 0.723, which is going to be 1 minus 0.27. What's it going to be? 7. 0.277. Right. This is a difficult concept to understand. Right? But let's see what we get out of it. Okay. So if you that's tricky. That's hard to get marks out of that one. Yeah, that's a hard question, to be honest. There's no two ways about it. Right? So, what we did here, we got this probability. I'll just show you where I'm looking. This probability and this probability is 484. 484 times by some number is 0.35. So to rearrange that, we divide by the 484 and you get this. Once we have this, this is the probability, this is the largest probability of a dry day, which means the probability of a wet day is the opposite, or 1 minus that. Okay? You said we want the answers, I'll leave the answers up here. Right? That is almost the last question. One more question left, I think. Yeah, one more question left. Okay? Right, let's move on to the last question. And then we're done. How do you apply the smallest equals largest to other questions? TNT, this is another good question. You're popping off, dude. You don't say much, but when you do, it's good. Right. So, the smallest equals largest concept. It's not really applicable to many other things. It's very situational. The only reason this exists is because of this information here. Because he's saying somewhere between here and here. Okay? If he just gave us a direct number, then we would know. I guess the concept is, right, the concept, let me find a blank page. This is gonna, oh yeah, there we go. The concept is that all probabilities are on a scale of 0 to 1, right? So, yeah, is it really smallest equals largest, or more like smallest equals? Yeah, you're right there. So the smallest of one thing is the largest of the other. So it's like this situation. The large. My wording is probably not the best. So if I have a large one of these, I have a small one of these because it's on this scale. So our other scale previously, that of the question we were just looking at, we had two situations: 0.3 dry or 0.35 dry, right? The largest amount of dry gives the smallest amount of wet, which would be 0.65, whereas this is the largest wet, which is 0.7. That's the concept. It's like this yin yang, right? Probability is like everything is 1 minus. So as one probability increases, the other must decrease. The probability of it being dry goes up, the probability of it being wet goes down. Right, really good questions from both those two people. Okay, tell me if that's answered your question, Uber and TNT. Right? And you guys are right. Is it really smallest equals largest? You're basically right. You're bang on the money. Okay, cool. Right, let's look at this last question. Nice, I like it. Nancy's friend Terry uses the NCEA data for the past 7 years to find out that 45% of days in Ashburton were wet, 35% of days in Timaru were wet. So she's just gone and like looked at all this data and calculated how many wet out of how many total, how many dry out of how many total. Then she makes this tree diagram. They've also provided this map. Now all my year 12s last year came up to me after the exam, said there was a geography question in the back of the paper. Right? Just use common sense, man. Right? Does the weather in Auckland affect the weather in Hamilton? Spam chat, yes or no? Does the weather in Auckland, or is the weather in Auckland reliant in some way or affected by the weather in Hamilton? Yes. Right? Is the weather in Ashburton, where's Ashburton? I don't even know where Ashburton is. Right? Is the weather in Ashburton, oh that's bad highlighter, affected by the weather in Timaru? Probably, because they're damn close to each other. Right? If it's raining here, if it's raining, then it's probably raining. If it's sunny, then it's probably sunny. Right? That is literally what they want you to think about. So, if we look at what the question is, they've said 45%. So they've just looked at a bunch of wet days and dry days, right? They've said 45% of days in Ashburton are wet, 35% in Timaru are wet. So I've constructed my tree, 45% are wet and 35% are wet. They have not taken into account the relationship between the two places, right? They have not taken into account, because this tree implies, let me get a red pen, implies a relationship but their numbers do not. The tree implies a relationship, but the numbers do not. Okay? So we just need to explain that in the question. Explain why Terry's tree diagram would not give a correct answer to the probability. And then this is like giving you the information. It's like, compare your answer from part A. So AI, where's my answer to AI? Compare this answer with the answer that with their tree. So we're going to do that first, and then we're also going to consult the map. which was talk about that whole thing we were just talking about. So, firstly, point number 1. Part A gave us the probability of 0.484 for, what was it probably of? Both dry, I think. I can't remember. Yeah, dry. Probability of dry, 0.484. How about the probability of dry here? Let's have a look. It's going to be 0.55 times 0.65. New tree. Probability of dry is 0.3575. Right? Then we just comment on it. These answers are different. Therefore, she has made a mistake. Then consult the map, right? Consult the map of Canterbury. This is where we go. Oh my gosh. Close to each other. Right? 2 places. What are the 2 places? Timaru and Ashburton are close to each other. Therefore, their weather is not independent of one another. There will be a relationship or pattern in their wet and dry days. She has ignored this or not taken into account or whatever. Okay. Right, I love this. Right? Isn't this question silly? It's like stating the obvious. Yes. And everyone crapped their pants. Right? If you just slow down and think a little bit about what's going on, you'll not be too bad. Let's have a look at what the answers wanted and see how obvious it was. Right, there's so much written here. From part A, I got 0.484, which is much higher. It's very different. Right? So our probabilities are different. That's the first thing we answered. Right? They've done the same thing here. Here are the key points. The towns are quite close together, so are likely to have weather on the same day. Similar weather on the same day. This is stating the obvious. I agree. Probably it's just reading. Have I said it again? Right. The probability of dry in Timaru will be higher if it is dry in Ashburton that day. I agree. If it's good weather in Hamilton, the chance of it being good weather here is pretty good. We need to have a look at this. Answers from candidates, like that's you, students, at this level should be in context and only informal perspectives on the idea of independence. However, to award T, the response must be a clear and complete description of the issue. Right? So a clear, developed connection between all the facts for E. So you need to write well. So it's not just reading, it's also writing. So this makes sense. Timaru and Ashburton are close to each other, therefore their weather is not independent of one another and there will be a relationship or pattern in their wet and dry days. She has ignored this. Along with this picture implies relationship, along with my calculation. The answers are different. She has made a mistake. That's probably not the right thing to say. Actually, she has made a mistake. But yeah, that's the E. So in this paper, they were really quite broad and deep with some of their E questions. Right? They were quite like loose. So like, explain why this situation is going on, and then they did like a hard E maths calculation. Thanks for the follows, team. And then the E in here was relative risk here, which is nice. But if you did something silly, you got it wrong. Then this is the weird E, comparing IQR to 1 standard deviation. And this was the nice E, or the other E that's just some hard maths. So it's like one maths concept and one like probability concept essentially per question for E. So one difficult maths, one difficult concept. That's how they tested it. Previous years it's not been like that. This year it was, or last year it was. So I don't know whether they're going to keep it or change it. The mock exams, I don't know either. Well, I do, but I can't say. That's us, team. We've done the whole paper. Right. Oh, we got a bunch of follows. Potato, Uber. Am I even supposed to be here? Venza. Gump. Samir. Thank you guys all for the follows. Very much appreciate it. If you want to drop a follow, drop a follow. Am I taking bribes? I'll take bribes, but nothing will happen with them, right? If you want to give me money, give me money. Right? I'll take it as a payment for the live stream. The free live stream that takes my time. Okay. Right. How many points to pass? Oh, good question. Let's have a look at the marking scheme. Right. So we needed 8 to 13 to pass, 14 to 19 to get merit, 20 to 24. My time we spent on Hearts 3 at the moment playing a lot of Overwatch. So you should give us money. That's not funny. Can't be done. You're coming to Nationals with the boys? Yes, I am. Tomorrow, bright and early. Apex Legends ads, not my fault. 1E8 is pass. No. 1E8 gives you 8 points. You need... Oh yeah, 1E8 is pass. Sorry, you're right. Yeah, 1E8 is pass. Far out. It's pretty good. Right. Easy E. Ibrex. Yeah, most people here are from NZ. Most of them are from my school. Where are you from, Uber? And are you a student? That's the question. Yeah, check out, was it Infinity Plus One? Great channel. Highly recommend. It goes into a bit more detail, but it's a bit less personal than a live stream. Infinity Plus One plug. And Mr. Chandake is awesome. From USA. Nice, dude. Fatman League, thanks for the host. Is it a host of... What is it? How many? Is it one of those? Yeah. A host with one viewer. Thanks, dude. Can I fail marks and try hard in exams? Not if you have measles. Thanks Fatman League for making me win a host with one viewer. Awesome. Right. National Maths greater than Infinity Plus One. Equal to. Oh no, I don't know. Different purposes. Yin Yin, yeah, nice. I like it. You got 51 followers, Yin Yin. Nice. 777 views. Guess how many views I've got, my dude. Get on my level, Yin Yin. Right, we're done. If you got any more questions, fire them away. Otherwise, I'll hang about for the last like 5 minutes or so. We'll turn the music up slightly. Did you guys enjoy having the music this time? I sort of felt like it was a bit. I've got no idea of what the levels are at. I don't even know if you could hear it. It was kind of nice. I thought it was kind of nice to have the music going. Do I teach calculus? No, I do not. I'm sorry. I do not teach calculus. I would like to, but maybe next year. Yifang is here. Yo. If I get +5 followers tonight, I will stream. I can probably give you 3. I've got 3 accounts. Do you teach at school? Yes, I do. That music's kind of loud. Yeah, I'm a math teacher at a school in New Zealand. Does it matter if we fail marks? I told you already. Of course it matters. Do you want to get into calculus next year? It matters. Do you want to get into any maths course next year? It matters. Benson won't get Chris in this class next year. I hope not. No, I don't mind him. I just wind him up. Yeah, I can make you a mod. What grade level? We don't do grades in New Zealand. It's like K12 is your top in US, right? So we're 1 year below that, I think. Is what this is pitched at. It's the 2nd year before you leave college. Yeah, you think I can probably mod you? I trust you. Mod Yifang. How do I do this? Mod. How do I do it? Do I mod / Yifang is cool 1. Can you go to page 11? In the questions? Sure thing, dude. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is this is not too bad, Samir. Do you want the whole page like that? I'll make it full page. Press F. No, I don't trust that. Slash. Oh, slash mod, not mod slash. Slash mod. There we go. Yifang, you're a mod. Is this actually lucky or is this like a fake lucky? I think it's actually lucky, isn't it? Or is lucky Yifang is cool like 1? Yeah, this is you, dude. You got 300 followers, so must be. Oh, you got more followers than me, dude. Damn. Am I going to algebra paper? No. Which is why I shouldn't bottom. Yo, true. No, I'm not going to do the algebra paper. Sorry, I don't teach the algebra, so I don't know it very well. So I can't give good advice. I can't really go through it too well. I'm not good at logs. I'm not good for much stuff. So I can only do what I teach this year, which is just prob and calc. Will I be in school tomorrow? Gerald, I will not be in school tomorrow. I'm sorry, man. How do I teach algebra to my class? I don't teach level 2 algebra. I teach level 1 algebra. I can do that. I can do level 2 algebra. I just can't teach it well. Right? Being able to do it and being able to teach it are very different skills. Benson's a wagon. Nah. I've had probably 5 sick days in 3 years at Roskell. And one was because I got stuck at the airport. What's seen at NZ in terms of students learning computer programming early? Not good enough, to be honest. I try to do it a little bit in my class. It's not like rolled out to all schools in New Zealand at all. We're getting a new curriculum very soon, and part of that it's called the digital curriculum. So it's gonna like change things quite a bit. But unless students take it as an option subject, it's pretty bare, which kind of sucks because if you can't think like a computer in terms of programming languages and stuff like that, you're going to be at a disadvantage when it comes to career choices, employment options, things like that. So like even just like the basics of programming would be amazing. If else conditional probability sort of thing. Just and like different gates and things would be kind of just like logic would be really good. Either self-learn early or you have to take it at a uni course. Yeah, it's basically right. Programming since the age of like 10. Nice. What do you do for a living? Uber X. Yeah, you thanks being on the money. I did engineering and I started programming for the first time, first year uni, and it got crazy pretty quickly. Yeah, thanks for the follow, mate. Thanks for the follow, my dude. Oh, maybe it is meant to be Uber. Nah, it's Uber X. What language you write in? I did a lot. I did mostly like C and C+, to be honest. But I started in like what they call Jython, which is like educational Python. You think you can't be a mod and plug your own channel, dude? Yeah, Jython. Yeah, that was like what I had no choice. It was my uni. It's my uni course. What'd you do? You guys are getting deep tonight, man. What the heck? Why'd you choose to be a teacher? Long story, Fat Pikachu. I can tell you, but it'll take like 3 minutes. Do I know any teachers from Rangi? I don't think so. You got a Rangi spy? No, I don't think so. Let's become undemon. Answer the question: who's top chatter? Who was the top chatter? It's got to be you, right? You've been chatting the whole time. How do I see? I think it only tells me about the last stream, not the current stream. Yeah, sorry. But you got banned. Yeah, but you spammed. Am I going to do the calc paper? Alex, oh, good to see you, Alex. No, I'm not going to do the calc paper before your mock, sorry. I'm going away, so I can't. I asked a bunch of people, they said, do the prob, do the prob, do the prob. So, not going to do the calc paper before mocks, but I will do a calc and prob paper before the end of the year. Or at least I'll do calc before the end of the year, because we've done this already, so I'd probably just post this. But maybe I'll do the 2017 probability paper and the 2018 calc paper. Yeah, Yufang is happy to tutor. Probably Yin Yan's probably saying, if you come to gaming club, dude, you can get tutored all the time. Oh no. Classes until 6. Yeah, that's rough. Gonna stream chemistry papers. Yeah, we should do that sometime on stream, right? The Monty Hall problem is so good. I do it with my juniors quite often. Jog, you're gonna get banned, man. You're gonna get timed out. Yeah, gaming club is basically dead till next term. You're right. But yeah, the Monty Hall problem is really good. I went over it in depth with like some colleagues the other day, and we were thinking about it a lot. Like why we're trying to understand it. Like I understand it from a probability perspective, but why it works, and we like really delved into it, and it was really interesting. But there's a lot of things I wish I could just teach. If I could teach without an assessment, it would be so much fun, right? But then how do I know if anyone's learnt anything, right? And you just rely on people being like good learners. It would be awesome to like turn this channel into just like a pure learn what you want, do what you want. Or, like I just like go over cool math stuff and people listen, but I don't think so. Um, yeah, I still laugh at your friends. Yeah, dude, mathematics, a good understanding of maths makes you like, um, I don't know, makes you, what am I trying to say? Like, not look down on people, but sort of makes you, I guess, laugh. Even on the inside a little bit. Like, like the gambling fallacy, right? If I, or someone who, I heard someone the other day say, uh, oh, my auntie has had 5 boys all in a row, and she's pregnant again. She's she's bound to have a girl now, finally, because she's had 5 boys. Right? On to page 8, yeah. Or they say, uh, she's bound to have a boy because of the previous probabilities, right? Just the idea that previous runs affect your current about to happen. Cool Maths Games. We've done a Cool Maths Games stream, Yifeng. We've done one because I had to do one more stream in a short condensed amount of time to get Twitch affiliated. And now we need like a concurrent 75 viewers to get the next Twitch goal. So I don't see that happening for a long time. Blocks for us level 1 to 33 speedrun. I do like that game a lot. We could try like, yeah, we could, I don't know. I have a person who wants help with his last engineering project in uni. Tell me more. I played since primary. 15-minute queue. Yo, what do you think of roll queue, you think? I'll give it 3 more minutes till 8:35 and then we'll call it. It's okay. Would you help him? I need more info, Panda. Talk to me next week. I'm not at school for the whole week, but talk to me next week. Oh, you're on exams. Message me on Discord or something. I like helping people. You know, I want a blocks for a stream right now. I would love to do a blocks for a stream right now, but I think it'll get boring pretty quick. If Uber Eats is still here. Yo! An anonymous chair, 100 bits, dude. Wait, 500 bits. Yo, what the hell? Ain't on 100. Ain't on 100. Yo, thanks, dude. Or dudette. That's crazy. That's a big chair, man. You're by far the top cheerer. Well done. I don't think you'll be beaten in a hurry at all. Yo, that's way too kind. Thanks, my dude. That's too much. You didn't need to do that. Thank you. You wish you had your mum's credit card so I could be top fan. No, not worth it. Don't do that. I would probably get in trouble, to be honest. Okay. Imagine the new, like, the way you got to think about this is imagine the news headline for the worst case scenario. Right. Maths teacher charges. Yeah, like the NZ Herald. Maths teacher charges students for online streaming on video game website or something like that. I don't know. Yeah, steals mum's credit card to be on top fan for Benson stream. I don't know if that would be the news headline, but yeah. Rex, what do you do for a living, dude? Or are you still studying? I'm assuming you're an adult. Can you explain page 8A? Yeah, of course. Very quickly, let's have a look at this. So, Samir, you need to tell me, do you understand this probability tree? Why did it do that? Right code, some reason they pay me. Nice, dude. What sort of a company you work for? Samir, do you understand this probability tree? Do you understand the tree? If you understand the tree, the next part's really, really easy. If you don't understand the tree, I can redo it from the start. Yes, he does. Perfect. Okay, so to find, the question is, find the probability it was dry in both Ashburton and Timaru on a randomly chosen day. Right, ignore the randomly chosen day part. That's sort of just like in there to scare you. The probability that it was both dry in Ashburton and Timaru. Dry in Ashburton is here. Dry in Timaru goes to here. So to find this probability, we multiply these two numbers and we get this. And that will give you this probability. Okay. Tell me if that makes sense, Samir, please. Vodafone, my friend works for Vodafone. Right, code, just another tech company. Is it the name of the tech company? Just another tech company? That would be a good name. Oh, sounds good. I hope you enjoy writing code. Not everyone can enjoy it. They can't stop all of us if we wake tomorrow. You'll be surprised what they can do. Right. What did I major in uni? I majored in what's called product development. Right, so I looked at design and automation and process management. So how to make processes more efficient. And then I minored in mechatronics, which is like mechanical and robotics. So combining those two things to make products more efficient and faster and better. So how to like manage a production plant and how to make sure that's good, but also at the same time how to like design a product so that it's actually successful and good. That's what I do in my free time, so that's why I get paid for doing something I love. Yeah, this is what I've been trying to explain to all teachers. Sorry, to all students, that you're better off to get paid for what you love doing than to just have a job that's just a job, you know. Good that Samir understands it. I still don't kind of understand the tree. Could you explain it again? Yeah, sure thing. Let's do it quickly though, because I'm about to check out. So you've just got to strip it from the sentence. It's hard to do, but you just got to strip it from each piece. It was wet on 45% of the days in Ashburton. So wet on 45% of the days in Ashburton. That's where this has come from. If that's wet, then 55% needs to be dry. Okay, sorry, it's small again. Then it says, if it was wet in Ashburton, the probability that it was wet on the same day in Timaru is 63. If it's wet, which is here, then the probability of being wet is 63, which I got from here. And then I do the opposite, 1 minus this to find this. Same thing here. If it was dry in Ashburton, probably that it was dry on the same day is 88. If it's dry, the probability of being dry is 88. And then you subtract from here. 1 minus this should be this. And you're away laughing. Hopefully that's enough. Little Wag Mox, go for gold. Right? You will be the only person that suffers in that situation. Can you write my name down as a teacher for job applications? I don't really know you that well. There's teachers that probably know you better. But if you can't find a teacher that's better, come talk to me in person. Is the best. Okay? Like I know you well, but I don't know how well you work, right? Just want to apply to Mac. It doesn't matter. You should still get someone that can give you a accurate what's it called? Reference, right? Feels Magus, man. Yeah. Right, let's call it. How do I make emotes? Because we need like I think we need an easy E emote. And what was the other one? Can you explain Bezier curves to us? Probably not, to be honest. Oh, and a big brain emote. Big brain, small brain. Yo, we need some of those emotes. If someone makes those, I'll straight up put them in. If you make a good easy E and a big brain and a small brain. Okay. If someone makes it, send it to me on Discord or via message in here, and I'll put it in there. I don't know how, but I'll somehow figure it out. Do you need to be? Surely I can have it. Okay. Other than that, guys, we're gonna call it. I've got to go clean my fridge, literally clean the inside of a fridge, and I also have to get up at 4 AM for barbershop. Okay. Thanks for everything. Ubix, really nice to have you. Awesome questions, by the way. Thanks for coming in, guys. Hopefully it's helpful. Have a great night. Hopefully you've made use of it. Thanks for sticking around at the end. It was really fun having a chat to you guys. And if you see me around school and I don't know who you are, say, "Sir, I was so and so in the chat," or just give me the little like nutshell math NSD little nod. No, nutshell math NSM, little NSM nod. Okay, right. I'm gonna call it. There's no feedback forms. I'm done with the feedback forms. Right. Later, ball. See you guys. NSM. Have a great evening. Thanks for watching.